everybody, my name is Jared Tate, the founder of the DigiByte blockchain, and welcome to part 2 of my 3-part video series on the upcoming version DigiByte 8.22. So what are we going to cover in part 2? Well, we're going to cover some of the bugs and issues that are currently holding up a release, or at least the test release of version 8.22. To start out with, first of all, I'd like to apologize for part 1. The audio, I know a lot of people said we're really low. I should have this fixed on part 2. So, what are the major issues currently holding up a version 8.22 release? Well, there's actually kind of 4 main areas, and I'm going to go through those one by one. So, what is the first major holdup and the major issue? Well, the first issue actually has to do with Dandelion. So for those of you, let me just tweak this a little bit so I can move stuff around so you can see my screen, and I'll walk you through this stuff. So yeah, Dandelion is effectively a privacy feature that was added to DigiByte several years ago that allows, when a transaction is broadcast to the network, instead of just instantly sending it out to the entire network worldwide, the transaction goes through what's called the stem phase, where your IP relays it to only another peer, who then relays it to only one more peer, and it takes a series of hops up to 99, and it's random. And the idea being somebody can't discover your IP address and link it to your wallet address. So it's done for privacy and protection. Because just like on Bitcoin and other crypto networks, there's nodes out there that are attempting to map wallet addresses with people's physical IP addresses. So that can be quite dangerous if you hold a large amount of crypto and somebody targets you. So Dandelion was created as an enhancement originally for Bitcoin, but Bitcoin never implemented it because it was actually too complex. If you read some of the developer discussions, they actually abandoned it. Well, we were the first ones to add it. We've had it for several years. But unfortunately, because as I talked about in my last video, the amount of refactoring due to the changes in the C++ language, there's actually a lot of issues and conflicts that we've ran into over the last year with Dandelion that have effectively caused it, led us to basically need to rewrite a large chunk of it. So that refactoring, while good, also causes issues, especially with something like Dandelion. So the big issues that we've ran into, we had a crash bug where when Dandelion attempted to basically relay a transaction, it would actually crash the client. Now we fixed that. However, there's still some more issues. So one of the things you got to know about Dandelion is it has its own system for storing transactions called the stem pool. Well, in the regular client, you have what's known as mempool. And mempool is where a transaction goes before it becomes part of a block and is officially recorded in the blockchain. So the mempool is constantly changing, but the mempool is shared network-wide. Well, as I was discussing earlier, with Dandelion, in order to prevent other nodes, except for the single node you relay the transaction in the stem, you have to have a separate system called stem pool. So we've ran into another bug where effectively, and you can see these issues if you go to DigiByte Core on GitHub, that's what I'm looking at here. There's been a bug because of refactoring where the transactions actually added to mempool twice, and we're still working out some issues there. It's been quite the pain to track down. So we're still working through that. The second issue that I actually just discovered here recently is a bug in replace by fee. Now, I have yet to write up and present an issue with all the details I've discovered. I plan on doing that in the next few days. But the gist is replace by fee is a feature that we decided to take out of 8.22 because we basically don't need it. It was originally designed for Bitcoin, where if you send a transaction, it wasn't accepted, you're waiting on it for several hours, you could actually replace the fee, bump the fee, and get a better chance of a miner picking it up. Well, that's really never been an issue with DigiByte because our blocks are so fast and our transaction fees are so cheap. So there's a lot of unneeded features. But I recently was sending some transactions in 8.22 And when combining multiple inputs to form a new transaction, it actually errored out and crashed the client. So, that's a problem and not something we want to release. It's always been one of my big things. If sending and receiving, there's any issue whatsoever, not even a test client. So I'm going to write that up. I think that's going to be a fairly easy fix, but it's something that still needs to be done. So third thing, this is where the discussion gets a little bit more interesting. And the third question regards the DigiByte supply curve. So there's been a lot of discussion over the last year. Thankfully, some very talented people, including Yoshi, Smart Array here on GitHub, as well as others, basically discovered an issue that the DigiByte supply curve. So the idea is there will be 21 billion DigiBytes in 21 years, right? Well, they actually discovered a problem where when the supply or the reward, the mining reward, drops to 1, instead of going to 0, it continues to just mint 1 DigiByte. So technically, even though this won't happen until the year 2035, you're talking about basically an infinite supply, which is something we don't want. So like I said, this current issue that was discovered won't be an issue until the year 2035 or so. But, it's something we need to fix, and we are going to fix. So I'm actually going to run you through a demonstration of exactly how to test this, how to verify it, and then also basically how we can fix it. So once again, Yoshi wrote up a amazing write-up here detailing the problem. I would encourage you to go look at it. And he also did a lot of work to refactor the subsidy code in actually this refactoring was pushed out in 7.17.3, but he details the issues here. Now, part of the problem we've ran into is there's this problem in computer science with timekeeping. It's actually the reason we have atomic clocks, and universal UTC time is actually a average. I think it's like 450 clocks around the world at different universities. Because everybody's local machine on a blockchain can have a slightly different time, and over a period of years and decades, your computer time can be off, several hours, even days. That's actually kind of an issue over the long time span of a blockchain. So, when we originally did the math code, when DigiByte launched 9 years ago, and after several hard forks, there's been some variations in there and some things that have got out of whack that have basically led to the point where we do need to adjust the curve and reward decay so that way we hit 21 billion DigiBytes mined at exactly 21 years. Now, that's actually even still hard to do because of these issues in timekeeping and computer science, but it's possible. So I'm going to go ahead and run through a demo here for you of exactly what's going on. First of all, the code that's controlling this subsidy reward can be found in validation.cpp, starting around line 1198. And I've had to make some modifications here in order to test this in Regtest. If you don't know what Regtest is, it's basically something called regression test. And it's a little different than testnet. So we have three main levels to basically test when it comes to a blockchain like DigiByte or Bitcoin. You've got mainnet, which is kind of hard to test, especially some issues, and you don't want to be testing stuff until you know it works, but you still want to test it on mainnet. Then you have testnet, where you have peers, so you can have multiple nodes, multiple peers, and it effectively functions the same way as mainnet. But then you also have what's called Regtest mode or regression test, which is local to your client. You can basically go create as many blocks as you need. You create your own private blockchain, and it's much easier to test. So for most developer applications, I know a lot of people have had questions with testnet. I would encourage you to use Regtest, and I'm going to show you exactly how that works here. So let me actually use Regtest to go through and not only show you what 8.22 looks like, but I'm actually going to demo this infinite supply bug and basically show you how we can fix it. So I open up Regtest here, which you add that to your .conf, Regtest equals 1, and the wallet will actually open, the icon will be red and it'll be in Regtest, but it's effectively the same wallet. So this is the new 8.22 interface. When you first create a wallet, you actually have to create a wallet from within it. So I'm going to call this test 1. As you'll notice here, you have a few options: disable private keys, make blank, or descriptor wallet. Descriptor wallet's also a new feature in 8.22. It allows for advanced script pub key management. That's something we can get into in another video. But that's probably the biggest new thing in the GUI. So with that, I can create this new wallet. If I wanted to create another one, I could come up here and say test 2, create that, and then it gives me a little drop down up here in the upper right hand corner, and I can actually swap between them. So I've had several wallets open. I think I had 10. I don't know if there's a limit. Makes it super handy to switch between different wallet.dat files. So for any of you that in the past have had to manage multiple wallets, it's kind of been a pain, but this new feature, multi-wallet feature, makes it much easier. So test 1, first thing we're going to do is we're going to go to receive. We're going to create a new address. We're going to copy this address and click OK. Go back to the home page. Now what we're effectively doing here is, after I've made several changes and tweaks to chain parameters for Regtest. So basically, over the history of DigiByte, we've had multiple hard forks, and then there's been multiple periods in DigiByte's history where the reward has been different. Effectively 6. So like I think I mentioned earlier, Yoshi did an awesome job in 7.1, 7.3. He refactored this and clearly laid out period 1, period 2, period 3, period 4. I had to make some tweaks to make the decay faster, because obviously we're not going to sit here for 21 years and wait to test this. So we have to simulate that, and we do that by lowering the threshold and how much time it takes for that decay to happen. So this first demonstration is what I'm going to show you is where, when the block reward drops to 1, it just stays 1, which is not what we want, because technically that's infinite, although that's not a problem that we'll run into until 2035. The idea is with 8.22, we want to make 100% sure that DigiByte supply does drop to 0, and there's only going to be 21 billion DigiBytes ever created. So this bug is actually caused by this issue right here on line 1269. But to demonstrate this, I'm going to open up my console, which is available in any DigiByte core wallet. I'm going to go generate to address. I'm going to generate about 1,200 blocks, which should be enough to go through the entire reward decay sequence that's simulated. I'm going to hit enter. And because it is Regtest, this is done in just a few seconds. As you can see, it returns the public or the addresses for all those blocks. And as you can see here, the most recent blocks mined are 1. Now, if I come up here, adjust this to 1, as you can see here, as I scroll down, there's this infinite amount of 1s, which is what we don't want. And then you can see here the simulated decay, which was set to basically occur every block, and then all the way back to when mining first started. And as you can see here, these first higher blocks were to reward new miners and to help the network grow, which actually worked to get DigiByte started. But, you know, all that was 9 years ago now. So currently the reward is set to decay every month, you know, until we get to 2035, when it's supposed to drop to 0. So that obviously isn't supposed to happen. So how do we fix this? Well, I'm going to actually demo this fix for you. Like I said, this one line of code, literally, because this coin constant is set to equal 1, we effectively need to change this to 0. Now, the permanent fix for this will be not only this change, but it will be other reinforcing parameters to help make sure this, as well as finally a consensus change to smooth the decay curve out. So I'll talk more about that in a minute, but let me just demonstrate this. So in order to test this change and to show you and prove to you that this will get rid of that issue once and for all, I need to come over here to my command line, and I need to clean the directory. And if you've never seen DigiByte core compiled, I'll show you how. The first thing we need to do is go to autogen.sh, which basically will create a build script that we can then use. I need to change a couple other parameters over here if we're going to retest this. You know, when I first built DigiByte, I think it took me like 3 hours to just, I had to sit there waiting for it to compile. I can tell you 9 years later, one of the things I'm thankful for is bigger, more faster computers that allow this to happen in a matter of seconds. So we're going to run the configure script next. Once it's configured, then we'll actually tell the compiler to build the new version of DigiByte Core so we can test it. And then we'll test it, but I'll show you how fast this is. And this is a pretty tedious process. You know, if you make changes and test it, literally we have to make the change, compile it, test the change, and go back and forth. So this is actually one of the reasons why development can take so long with the blockchain. And that's not even testing it on the network, you know, etc. So the next command, so basically this is going through and making sure I have all the dependencies on my local computer in order to compile DigiByte Core. So after the configure script is run, should be done any second now, we will go ahead and then we will actually give it the make command. And notice I'm going to write make J8, which actually is going to use all 8 cores on my MacBook Pro. And this is going to zip right along. And it's actually going to be a lot faster. Well, I've actually previously compiled it, so it's only redoing the part that it needs to change. Then I'm going to do a make deploy, which makes the DMG installer. And then I'm going to reinstall it over here on the left once that's done. And overwrite the previous version. And then I also had to delete the Regtest folder because, you know, there was 1,200 blocks we don't need from the code change. So that's done. I'm going to go ahead and drop it in here real quick. Replace. Okay. Eject. Now I'm going to boot it up again. Where I can find the icon. Let me just make sure I have it replaced. There we go. All right, I'm going to boot it up again. Here we go. Got to go create a new wallet, test, subsidy, fix, create. We're going to go to receive, create a new receiving address, copy, go back to overview, turn it over here. And we are going to do generate to address 1200. Boom. As you can see here, it's going to go through the decay and it gets to 0 as we want it to. So as you can see here, as soon as, whoops, we got to organize by amount here because it generated them so fast, it kind of mixes them together. But if we go, as soon as the reward dropped to effectively 1, then it goes to 0, which is what we want. So there you have it, proof in 8.22. We will fix this infinite bug and make sure. Now, in addition to this, we will add some hard cap limits and other part of the code base that make sure at 21 billion coins, it drops to 0. Now, we're doing that to make sure 8.22 enforces this. And like I said, this problem isn't an issue until like 2035. However, we don't know exactly when that point will be because, like I said, this issue in computer science with time variance, I mean, like I said, the reason we need atomic clocks. So what my proposal to fix this is to do this step that I just said because the problem was caused with 1 line of code. We changed that 1 line of code. And then second, add some more hard basically limits another part of the code base, which I'm going to put together a PR as well as some other devs and we can talk about that. Or I'll show you that once that's done. And then also the final phase of this to smooth out the decay curve. So basically we want a smooth gradual reduction, ideally until January 10th, 2014. Or I mean, not 2014, excuse me, January 10th, 2035, which is 21 years. And that's been the original idea, 21 billion digibytes in 21 years. But to do that adjustment to reward decay actually requires a hard fork. So since we have roughly, you know, what is it now, 12, 13 years to fix this, whenever DigiByte does its next hard fork, that's where the third part of this, the reward smoothing, should happen. But before then, 8.22 will have hard limits enforced, and as I just proved to you, the reward will drop to 0. So that is that. So the next part, I guess, of the 4 issues is actually not necessarily an issue itself, but that is the possibility of a hard fork for a new mining algorithm. And that discussion I actually want to go over in part 3, because I'm going to go into extensive detail on hard forks, the history of DigiByte hard forks, as well as the new potential mining algorithms. So the current proposed potential new mining algorithms for DigiByte are RandomX and ProgPow. But in order to implement those, it would require a hard fork. So that brings me to the next question. And that is, here we are almost a year and a half into 8.22 development. Should 8.22 include a hard fork, or should it just include a soft fork for Taproot, which is 100% going to be required for Taproot, which, like I said in my previous video, is a very significant upgrade that I think is good for DigiByte. My personal stance is 8.22 should just be a soft fork, because we've already spent so much time on it. If we are going to hard fork, it's going to take us another, year and a half to 2 years before we get all that done and over with. So I'm a fan of any algo swaps, or any reward decay curve adjustments happening in version 9 of DigiByte. The other reason I say that is there's so many changes that are in this version. The more we change, the broader our potential attack surfaces, and the more likelihood that we're going to have unknown bugs. So while changing a bunch can be good, changing too much can be, a problem. So I personally am a fan of just doing the Taproot soft fork, holding off on any hard fork changes until basically a version 9, and we have more time to develop those and test them. Like I said, we still have some bugs that are pending. I would like to get a test version of 8.22 out once these 3 issues are taken care of. Like I said, Dandelion replaced by fee, and then the hard limit for the supply, the mining reward. So lots have changed. I hope that kind of gave you a little intro, if you've never seen Regtest, or if you've never seen DigiByte compile before, exactly how that works. But with that being said, I want to keep this video a little bit shorter. Like I said, stay tuned for video 3 of my 3-part video series, where we are going to talk about potential hard forks, algo swaps, and more details. So with that, if you like this video, please subscribe. I'm doing this all volunteer right now, so you subscribing to this channel hopefully can help me fund some development in the future. So with that, cheers, take care, and have a great day.